So opposite r over 83. I need to get r by itself, which means I need to multiply this side by 83, and that's going to turn to 1. Well, what I do to one side, I have to do to the other side, so that's 83 times on this side. So we're going to have 83 times that tangent of 32 degrees is going to equal my r. And round it to the nearest tenth, what does my r equal? Yeah, 51.9. Was that 51.9 degrees? No, because it's a length. It's a length of a side. All right, so r is about 51.9 degrees. For our next one, we have to use tangent. That's the one we know. So I'm going to say to solve for a, I need to do tangent of a equals opposite, which is 8, over, can I use the hypotenuse? No, so in fact I'm thinking I can't use it at all. So that's only left with 6, 8 over 6. Does that say a equals something? Did I solve for a yet? I did not. I'd have to do the tan inverse of both sides. Or we could just remember, if I'm looking for an angle, measure of angle A equals our tangent inverse of 8 over 6. So I jump right to that. If you missed that, you would have to realize that you need to take the tan inverse of both sides. So I would take the tan inverse of this side. My tan and tan inverse turn to 1, and that's what leads us to this angle A equals tan inverse of 8 over 6. To shortcut that method so you're not writing this down every single time, just remember, if I'm missing a side, I have a degree. So once that degree is in there, I can type this in my calculator. If I do not have a degree, I can't type tangent A in my calculator. So that's going to tell you I need to find the angle, which means I'm using tangent inverse. All right? So just be aware of that. If I'm looking for an angle, it's angle equals tan inverse. If I'm looking for a side, it's tangent of whatever degree that angle is equals something over something. Well, opposite over adjacent, okay? Keep those straight in your head. Don't use the wrong one at the wrong time. You get a completely wrong answer. All right. We're supposed to draw a triangle based upon the tangent ratio, and I'm supposed to solve for the missing variable. Well, these can only be right triangles. That's all we're dealing with is right triangles. Tangent only works with right triangles. So I know I'm going to be drawing a right triangle. So let's go ahead and draw a right triangle. That's my right triangle. And I need to label one of those angles A. Can someone tell me which angle I don't want to label angle A? There's only one that I can't. There's only one that I can't. Lauren?
The 90-degree angle?
I can't label this one A. Otherwise, whichever one you pick is fine. So I'll pick that top one. I'm going to call this top one angle A. If you label that bottom one A, you leave it. Don't erase it. If you label this one A, you're fine. All you have to do, and all I'm asking you to do on this problem, is since tangent A equals 6 over 14, we're going to say that opposite side is 6. The adjacent side is 14. I promise you problems like this are going to show up again. Hint, hint, it'll probably show up on the test, right? This is all I'm asking you to do. I'm not asking you to find your missing side. All right? You don't have to use the Pythagorean theorem. This is good enough for your drawing. This right here is good enough for a drawing. Now we need to solve for A. Uh-oh. Is A by itself yet? So when I find an angle, what equation do I use? Bree?
The tangent inverse.
The tangent inverse. So can you just walk me through it real quick? How would I write it?
Angle A equals tangent inverse times 6 over 14.
Perfect. Tangent inverse of 6 over 14. And if I wrote it up this way, it would just tell me my tangent. I can't do tangent of A in my calculator, so that's why I have to do tangent inverse. And someone besides Bree, tell me what angle A equals about. 23.2? Anything important about that 23.2? Degrees, thank you. That's important. It's important to write that it's degrees. That you understand that that is actually an angle. It's not a side, it's actually my angle. All right, if you haven't already, I want you to do the second one. Draw your triangle, label the sides you can, and solve for x. Yes, cool. If you want, you can move on to the next one too. If you got that one down, you can go ahead and move on to the next one because it's almost the same. It's just a lot of practice again. Because we do have a test next Wednesday, so the better you know the stuff, the easier it's going to be. While you're working, I'm going to draw my triangle. You can keep working though. All I'm doing is drawing my triangle. Oh yeah, you got it. That's correct. Is my triangle correct? Look up there. Does it have to be exactly the same as yours? Could you put that 60 degrees on the top angle? Yep, you just would have had your x and your 5 switched. All right. Well, they almost have the whole equation written out for me. I have tangent of 60 degrees equals x over... Can I put tangent of 60 in my calculator? Does that work? Yeah. So the only thing I have to do is get x by itself. To get x by itself, I'm going to multiply both sides by 5. So times 5, that will turn to 1. But what I do to one side, I have to do to the other side. So we are going to say that x equals 5 times tangent of 60 degrees. And who got that? Actually, everyone, almost everyone. 8.7, right? Am I going to put 8.7 degrees? Am I going to put 8.7 degrees? Alec, am I going to put degrees on this? No. Because it's a side. All right, let's do the last one really quick. I'm looking for an angle, right? Can someone tell me the equation I need to write to find a missing angle? Mary. Can you say the fraction ones?
5 over 8.6.
Yep, 5 over 8.6. And someone besides Mary, can you tell me what this comes out to? Great.
30.2. That's what I got.
I know, I'm waiting for something else.
Oh, degrees.
Degrees, thank you. That's important. It wasn't that you were wrong, it was just that you didn't give me a complete answer. Alright, just like with feet, inches, degree is an important thing to write on there. It's important for you to realize that we're talking about an angle, and it's important for someone reading your work to know that you're talking about an angle and not some length. Alright. The next we're going to talk about, and you got some problems like this in your homework, is an application problem. If you've ever driven on like a steep road, you'll see like a sign that says like it has a 7% grade. It's telling you basically if it's going downhill or uphill. And generally those are made for big trucks, like semis and stuff, because semis have a hard time with brakes. And if their brakes go out, they got problems going down the hill. So they're just basically telling trucks to get into a low gear. So grades are really important, especially around mountain towns. Anyone that has mountains, grades are very important. But what does 4% actually mean? What does 4% actually mean? Yeah. It tells you basically what angle you're at. But they don't use degrees, right? Wouldn't degree make more sense sometimes? Like if it's like a 30 degree, I know I could picture 30 degrees. But instead roads use 4%. So sometimes it's nice to be able to change that into, rather than saying 4%, what degree it's actually going up. So that's what this question is saying. It says find the angle that the road makes with the horizontal. So that means we have a horizontal line and we got something going up. if its grade is 4%. So the first thing I'm going to do is I'm going to draw my road. So it's got a grade of 4%. We're just going to say it's going uphill. So I have a road going uphill. And it says, what is that versus a horizontal road? So this is my 4% grade versus if my road would go straight. Well, that actually creates a 90-degree triangle. And now we have to think about what 4% means. 4% is actually a mathematic thing that is read as 4% stands for 4 per 100. So remember, a percent can be written in two different ways. It can be written as 4 per 100, or you can write it as 0.04. All right, that's what 4% stands for, 4 per 100. 4 per 100. So if we look up here, it's actually a rise over run function. That's what this degree says. So for every 100 feet it goes up 4 feet. So when we're using percent, it's going to go up 4 feet over a run of 100. So up 4 feet every 100 feet. So up 4 per 100 feet. Up 4 per 100 feet. Now I want to figure out what angle that is. Call it whatever you want. I'm just going to call it A. I'm going to call it angle A. And I want you to go ahead and solve. Tell me what angle am I actually going uphill? What is my actual angle? And generally these angles aren't going to be huge. Because if you're going uphill 90 degrees, that means you hit a wall, right? If I have to go up 90 degrees. So these angles aren't going to be too huge. So when you're doing these problems, real world, if you come up to like 100 degrees, you got a problem because you're actually going like backwards up a hill, which doesn't make any sense. So I'm going to be kind of doing the work over here. And I had a good question in my first period. They said, do I need to simplify that 4 over 100? I would say no, because your calculator can do the work either way, right? All reducing this would do is you have to write another equal sign, and it actually increases your workload versus decreasing your workload. So if I was plugging something in a calculator, I would just plug in 4 over 100. What did we get?
2.3 degrees.
What did we get, Chris? Thanks for raising your hand. 2.3 degrees. 2.3 degrees. Does that seem like something fair that you could go up into the 2.3 degrees? Yeah, when you start getting huge numbers, that's what I'm talking about. Like, make sure it seems realistic in real world. If you're going like I said, if you're 90-degree angle, that means you're smacked into a wall. All right, so make sure you come up with realistic answers. Any questions about the grade? Okay, then let's go ahead and start our homework. No? Oh, I thought you said no. Oh, I thought you said no. No. Noah. Oh. So these questions are going to be a little harder. Make sure with these ones that have multiple triangles built into one triangle that you're just using the ones that make right triangles. Because tangent only works on right triangles. So that makes this 45. Yeah, that's what I would do. You could have done a tangent too. You could have said the tangent of 45 is W over 82. Came out to 82. Surprisingly enough, it actually works. But yes, I would shortcut it that way. Because they're asking for a percent, right? So if they're asking for a percent, then it has to be 100.
The diagonal is just like